Okay, see the topic, collision theory, activation energy and Arrhenius equation. So this topic is very important for your exams. Say the frequency of questions in different years. Say in JEE 2020 mains, 2019 mains, 2018 mains, 2018 advanced. See here, this is advanced topic. 2017 mains, 2017 advanced, 2016 advanced, NEET 1918. So see here, this topic is very important. Say what is collision theory? So say according to collision theory, for a reaction to occur, there should be collision between reacting species. Say the first condition for a reaction to occur is there should be collision between the reacting molecules. So the first condition is the collision. Right, see this is the collision of a reacting species. Now increased concentration of reacting species result in greater number of collisions per unit time, and this is known as collision frequency. If we increase concentration, say here, then the number of molecules also increases. So number of molecules increases means more number of molecules, they undergo simultaneous collisions. More number of molecules undergo collision per unit time. It means that here the collision frequency increases. Say here, but not all collisions are effective collisions. Say here, it means that whatever be the number of molecules, they collide with each other, and all the colliding molecules, they do not convert into products. It means that all the collisions does not result into reaction, or all the reactant molecules which undergo collisions, they convert into product. So they must have the effective collision. उनके बीच में effective collision होना बहुत जरूरी है. Now see what is effective collision. The question is what is effective collision. First one, for effective collision, the reacting species must have at least a certain minimum energy called threshold energy, right? Say here, this is a hypothetical energy barrier which reactant molecules must acquire, or they overcome this energy barrier, then after they convert into reaction, or then after they convert into product. देखिए सभी reactant molecules की जो अपनी एवरेज एनर्जी होती है, और उनकी एनर्जी इस एनर्जी के बराबर या इससे ज़्यादा होनी चाहिए, तभी वो रिएक्शन में कन्वर्ट होंगे, अदरवाइज वो रिएक्शन में कन्वर्ट नहीं होंगे. See with the help of graph, see this is the graph between the energy and the reaction coordinate, and this is the hypothetical energy barrier known as threshold energy, right? Now this is the average energy of the reactant molecules. Say this is the average energy of the reactant molecules. Now this is the hypothetical energy barrier. This is the energy required by the reactant molecules, then after they convert into product. देखिए जब तक reactant के molecules की energy इस energy के बराबर यानी threshold energy के बराबर या इससे ज़्यादा नहीं होगी, तो वो products में convert नहीं होंगे. Similarly, if the reaction is reversible in nature, so the product molecules, this is the average energy of the product molecules, and they require this amount of energy, means they have to overcome this energy barrier, that is the threshold energy. So their energy should be greater than or the equal to threshold energy, then after they convert into a reactant, right? So this is a hypothetical energy barrier, and it is different for different reactions. ये अलग-अलग reactions के लिए अलग-अलग होती है values, right? Now see here, see this is the average energy of the reactant molecules, and this is the threshold energy. So this is the difference between the threshold energy and the average energy of the reactant molecules. It means that the reactant molecules acquires this amount of energy, then after their energy becomes equal to or greater than the threshold energy, and they converts into products, or they convert into reaction. See, it means that this energy, so this is the additional energy required by the reactant molecules in order to convert into products, or in order to perform the effective collision. तो effective collision तभी होगा जब तक reactant molecules की energy इसके बराबर या इससे ज़्यादा नहीं होती, तब उनके बीच में जो collision होगा वो effective collision कहलाएगा. So this is effective collision. So this additional amount of energy required by the molecules so that they becomes active, they perform the effective collision for the conversion into products, is known as activation energy. See? So see, this is the definition of activation energy. So this is the minimum additional energy required by the molecules to attain threshold energy, is called activation energy, and it is represented by EA. So this is the activation energy, or this is the energy required to activate these molecules so that they can perform effective collision and convert into reaction. So this is the activation energy. Similarly, see here that these product molecules, they acquire this amount of activation energy, and then after their energy becomes equal to threshold energy or greater than threshold energy, and they convert into product. So this is activation energy. So we see that here the activation energy, it is threshold energy minus the energy of the reactant molecules, or you can say energy of the product molecules, right? So this is the activation energy. Now see here, the fraction of molecules having energy equal to or greater than threshold energy, यानी कि ऐसे molecules जिनकी energy threshold energy के बराबर या इससे ज़्यादा है, उस फ्रैक्शन को हम लोग f से डिनोट करते हैं, and this becomes e to the power minus e upon rt, and this is known as Boltzmann factor. इसको हम लोग Boltzmann का factor कहते हैं. So this amount of energy means this fraction of molecules, they undergo simultaneous collision. It means that they perform effective collision and they convert into reaction. तो सिर्फ यही जो fraction of molecules है, यही क्या करेंगे, effective collision करेंगे और ये reaction में convert होंगे, right? So these are the graphs here. कभी कभी आपसे ग्राफ पे बेस्ड क्वेश्चंस बनते हैं. See here. In this case, we see that generally the reactant molecules in this case require this amount of energy, then they convert into product, and the product molecules, they require this amount of energy and they convert into a reactant. So if the reaction is reversible, say here, in this case, here we see that the reactant molecules requires greater activation energy as compared to the product molecules. So generally we see that the rate of reaction, it is inversely proportional to the activation energy. So it means that the lesser with the activation energy, faster with the reaction, and vice versa. So see here, in this case, the activation energy of the reactant molecules is greater than the activation energy required by the product molecules. It means that here the forward reaction, if the reaction is reversible, then we can say that here the forward reaction is slow one and the backward reaction is fast. So we can say that here the forward reaction is slow and the backward reaction is fast, right? And we see here, this is the difference, means delta H. Delta H, we see here the energy of product is greater than of energy of reactants, so their difference will be positive. It means that in this case there is overall absorption of energy, means this is an endothermic reaction. So this graph is for the endothermic reactions. So in endothermic reactions, see here the value of delta H is positive, and in this case the rate of forward reaction is slow and the backward reaction is fast one, right? See this graph. In this case we see that here the activation energy required by the reactant molecules, it has lesser magnitude than the activation energy required by the product molecules. It means that in this case we see that, first of all, see the difference of delta H. See here, the energy of product is lesser than that of energy of reactants, so its value overall, its difference will be negative. It means that there is evolution of energy. So this graph is for the exothermic reactions, right? Now see here, reactant molecules comparatively require lesser amount of energy to perform effective collision. It means that here the forward reaction in this case is fast and the backward reaction is slow. So this is the case for the exothermic reactions. So these things are asked in your exams, right? Now, so this is the first condition. In order to perform effective collisions, it means that there must be effective collision, means there is energy barrier. It means that the reactant molecules must acquire this amount of energy. This is a minimum amount of energy required by the reactant molecules, then after they convert into reaction, or then after they convert into product, right? Now the second factor is that the colliding molecules must have proper orientation. It means that they have proper orientation at the time of collisions. See here, we have a reaction here. See, there is a reaction between the N2O and NO, nitric oxide, and the formation of product, this is N2 and NO2, right? See here. So in this case we see here the oxygen atom, it directly collides with the nitrogen atom. So this is a proper orientation of collision. So in this case there is formation of product. It means that it results into formation of products. So this is in proper orientation. So in such type of reactions we see there is formation of product. But see, in this case we see that here the nitrogen, here the nitrogen atom, it collides with the nitrogen atom of nitric oxide. So this is improper orientation. So this is improper orientation. It means that in such type of reaction there is no formation of product or there is no reaction, right? So proper orientation of the colliding molecules is also very important for effective collisions. तो अगर इनमें में से कोई भी चीज़ें satisfy नहीं हो रही है, fulfill नहीं हो रही है, तो effective collision नहीं होगा, और effective collision नहीं होगा तो reaction में conversion नहीं होगा, यानी reactants product में convert नहीं होंगे, right? So this is okay. Now see here, the fraction of molecules. So the fraction of molecules having proper orientation for conversion of reactants to products is called the steric or the orientation factor. Say here, अब ऐसे molecules जो proper orientation में collide कर रहे हैं वही effective collisions करेंगे, और ऐसे fraction of molecules को हम लोग कहते हैं क्या? This is the steric factor or the orientation factor, and it is represented by P, right? So overall we see that here the rate of reaction, it depends upon the three factors. First one is, that is the collision frequency, which is represented by Z. Second, it depends upon the steric factor, that is the P, that is the fraction of molecules having proper orientations and which perform effective collisions. And third one is, that is the F, means it is the fraction of molecules having energy greater than or equal to threshold energy. It means that the molecules which satisfy the energy criteria, right? So see here the rate constant K. So we can say that here the rate constant K, it is directly proportional to the collision frequency, it is directly proportional to the steric factor, and it is directly proportional to the Boltzmann factor, that is a fraction of molecules having energy greater than or equal to threshold energy. So rate constant here, actually rate constant is the measure of rate of reaction. So the magnitude of K, it represents the rate of reaction, it is a measure of rate of reaction. So we can say that here that the K is directly proportional to Z, that is the collision frequency, or it is directly proportional to P, or it is directly proportional to F. So we can say that the rate of reaction is actually directly proportional to the collision frequency, or it depends upon the steric factor, and that is the fraction of molecules having energy greater than or equal to threshold energy, right here. So see here, so we see that here K, that is the rate constant, this is equal to P Z e to the power minus E upon RT. This is F, this is the value of F, right? So now from this equation we get here K is equal to this value, P into Z becomes a constant, and this constant is known as pre-exponential or frequency or Arrhenius factor, right? And e to the power minus E upon RT. So this equation is very important equation and commonly known as Arrhenius equation, right? K here is the rate constant, E is the activation energy, T is absolute temperature, and this fraction, that is e to the power minus E upon RT, this is known as Boltzmann factor, right? So this is collision theory, and here we get a very important relation. This is known as Arrhenius equation. Now see the effect of temperature on the rate of reaction. See, this is the Arrhenius equation, K to the power, K is equal to A e to the power minus E upon RT. So from this equation we see that here the rate constant, it is a function of temperature and activation energy. It means that it depends upon the temperature and activation energy. See, it depends upon the activation energy and temperature, right? So generally with increase in temperature, the value of K increases. It means that here the K is directly proportional to temperature. That is, at higher temperature, the rate of reaction increases due to greater number of collisions whose energy exceeds the activation energy. So increase in temperature means with increase in temperature, kinetic energy of the reacting molecules increases. And since their kinetic energy increases, it means that their collision frequency also increases. Means more number of molecules, they collide with each other and their energy becomes greater than or equal to the threshold energy. It means that their energy exceeds the activation energy and they perform the effective collisions and convert into reaction, right? So this is collision frequency, right? So with increase in temperature, due to increase in collision frequency, the rate of reaction increases. Say this is the effect of increase in temperature on the rate of reaction. See here a graph is plotted between the fraction of molecules and the kinetic energy. This is known as Boltzmann distribution of energy. Say here, this is the graph. So with increase in kinetic energy, say here, this is kinetic energy, and see this energy, this is most probable kinetic energy. It means that it is the energy possessed by maximum number of molecules, and this energy, this is the average energy of the reacting molecules. So see here, obviously there is less number of molecules having average kinetic energy, right? Now see here, in this case we see that this molecule, let this be the criteria, energy criteria, or we can say this is energy barrier known as threshold energy. So it means that here this is average energy of reactant molecules. It means that this difference, so this amount of difference, this is difference, means this is the activation energy, means the additional energy required by the reactant molecules. Then after their energy becomes equal to threshold energy or greater than threshold energy, and they converts into reactions. So this fraction of molecules, they perform effective collisions and they convert into reaction. Now with increase in temperature, see here the T2 is greater than T1, so it means that with increase in temperature, this graph क्या हो जाएगा, it moves forward, it tilts towards forward, ये forward direction में move कर रहा है. Now see in this case, see here, now there is more number of molecules having kinetic energy greater than or equal to threshold energy. It means that here the rate of reaction increases, right? Since number of molecules having energy greater than or equal to threshold energy, it increases. It means that more number of molecules now perform effective collisions and they convert into reaction, right? So see here, with the increase in temperature, we see that here the kinetic energy of the reactant molecules increases, and the more number of molecules, their energy exceeds the activation energy, and they perform effective collisions and convert into a reaction. So we see that here with increase in temperature, the rate of reaction increases, or we can say the magnitude of rate constant increases. In general, with rise in temperature by 10 degrees Celsius, the rate of reaction increases 2 to 3 times. राइट जनरली ये देखा गया है कि 10 डिग्री टेम्परेचर बढ़ाने पे रेट ऑफ रिएक्शन 2 से 3 गुना बढ़ जाता है, एंड दिस इज डिफाइंड इन टर्म्स ऑफ टेम्परेचर कोफिशिएंट. द टेम्परेचर कोफिशिएंट इज एक्चुअली द रेशियो ऑफ रेट कांस्टेंट्स एट टू डिफरेंट टेम्परेचर्स हैविंग अ डिफरेंस ऑफ 10 डिग्री सेल्सियस. यहाँ पे देखिए ये टेम्परेचर कोफिशिएंट दो रेट कांस्टेंट्स का रेशियो है, और दो डिफरेंट टेम्परेचर्स पे, और उन टेम्परेचर्स के बीच का जो डिफरेंस है वो 10 डिग्री का है, और जिसका जो रेशियो निकल के आ रहा है वो आ रहा है 2 और 3. और यहाँ पे हम देख रहे हैं क्या K2 और K1 के बीच का रिलेशन हमें जो दिख रहा है, K2 is equal to K1 and this is temperature coefficient to the power delta T upon 10, right? So here in this case, if we have at temperature T1, let this temperature be 10 degrees Celsius, and at this temperature let the rate constant value is K1, and let we increase the temperature and it becomes 60 degrees Celsius, and let the rate constant value at this temperature is K2. So when we see the relationship between K2 and K1, so we see that here K2, this becomes K1, and let the temperature coefficient value in this case be 2, so this becomes equal to 2, and delta T means here the 60 minus 10 means it is 50 upon 10. So in this way we can calculate the rate constant values if any of the rate constant values given, right? तो हम क्या करेंगे, इसकी मदद से आसानी से अगर हमारे पास कोई भी इंफॉर्मेशन है, K1 का इंफॉर्मेशन है, तो हम आसानी से K2 निकाल सकते हैं, राइट? तो इस पर भी आपके न्यूमेरिकल बन सकते हैं. Okay, now say the effect of temperature on the rate of reaction. Say from Arrhenius equation. See, from Arrhenius equation we see that K is equal to A e to the power minus E upon RT. Right? Now see here, with increase in temperature, अगर आपने temperature को बढ़ाया, see here, so in this case we see that this fraction, that is E upon RT, देखिए जैसे आपने बढ़ाया तो E upon RT की वैल्यू क्या होगी, this decreases, ये डिक्रीज करेगी क्योंकि आप टेम्परेचर बढ़ा रहे हो, तो ये पूरा क्या करेगा हमारा, दिस वैल्यू डिक्रीजेस. और अगर ये वैल्यू डिक्रीज कर रही है, सो नेगेटिव ऑफ E upon RT क्या हो जाएगा, दिस इंक्रीजेस, तो ये पूरी वैल्यू क्या करेगी, नेगेटिव ऑफ E upon RT, दिस इंक्रीजेस. And this fraction, that is this fraction means e to the power minus E upon RT, this also increases. और अगर ये increase कर रहा है, so this value is constant, it means that the value of K increases. So it means that the rate of reaction increases, right? So we see that here the rate constant is directly proportional to temperature, or we can say here that is the rate of reaction is directly proportional to temperature, right? So we can explain the effect of temperature on the rate constant with the help of Arrhenius equation. Okay, now see the effect of catalyst on the rate of reaction. Say, catalysts allow reactants to occur via alternative pathway that increases the rate of reaction by lowering activation energy. Say here, see the role of catalyst. So catalyst actually alters the rate of reaction. Catalyst actually alters the rate of reaction, means it increases the rate of reaction if we apply positive catalyst, or it decreases the rate of reaction when we apply negative catalyst, right? So how it changes the rate of reaction? Say here in this case we have applied a positive catalyst, and there is a carpet with energy and the reaction coordinate. So here this is the threshold energy or the hypothetical energy barrier, and this is the average energy of the reactant molecules, and they require this amount of activation energy, and then after they perform effective collisions and convert into product. So this is the reactant, and this one is the product, right? Now we apply catalyst. We apply catalyst here. So in this case, this is the application of catalyst. This is the application of catalyst here, right? So when we apply catalyst, it develops an alternate path. ये एक दूसरा path develop कर दे रहा है. See, because this is the initial path. Now after the application of catalyst, there is development of another path. It means that how it decreases the activation energy. इसने क्या किया? देखिए, इस activation energy को decrease कर दिया and develops an alternate path, right? Now see here, the activation energy decreases. Activation energy decrease कर रहा है. It means that earlier we have seen that rate of reaction is actually inversely proportional to activation energy. So with decrease in activation energy, rate of reaction increases. जैसे आपने एक्टिवेशन एनर्जी को कम किया, रेट ऑफ रिएक्शन बढ़ेगा. इसका मतलब क्या है? यहाँ पे देखिए, इसने एक अल्टरनेट पार्ट डेवलप किया. कैसे? एक्टिवेशन एनर्जी को कम कर दिया, और एक्टिवेशन एनर्जी कम करने की वजह से क्या किया? इसने रेट ऑफ रिएक्शंस को बढ़ा दिया, राइट? If this is a reversible reaction, so see the effect of application of catalyst on the equilibrium condition. अगर ये यहाँ पे हम इनके बीच में अगर इक्विलिब्रियम है रिएक्टेंट्स और प्रोडक्ट्स के बीच में, तो see यहाँ पे इसने जितना एक्टिवेशन एनर्जी रिएक्टेंट्स के लिए डिक्रीज किया, उतनी ही एनर्जी इसने क्या किया? प्रोडक्ट्स के लिए भी डिक्रीज किया. सो इट मीन्स दैट देयर इज नो इफेक्ट ऑन द कैटलिस्ट के नो इफेक्ट ऑन द इक्विलिब्रियम कंडीशंस, यानी कि इक्विलिब्रियम कंडीशंस के ऊपर कोई फर्क नहीं पड़ रहा है. क्यों? बिकॉज इट इंक्रीजेस द रेट ऑफ फॉरवर्ड रिएक्शन एंड द रेट ऑफ बैकवर्ड रिएक्शन बाय इक्वल एक्सटेंट. सो देयर इज नो इफेक्ट ऑन द इक्विलिब्रियम कंडीशन, राइट? सो दिस इज द एप्लीकेशन ऑफ कैटलिस्ट. नाउ सी द इफेक्ट ऑफ एक्टिवेशन एनर्जी विद द हेल्प ऑफ Arrhenius equation. Say we have the Arrhenius equation K e to the power minus e upon RT. Now keeping t constant, यहाँ पे t को constant कर देते हैं and see the effect of activation energy on the rate of reaction, or we can say rate constant, right? So here with decrease in activation energy, इसको कम करते हैं. So with decrease in activation energy, we see that this value means E upon RT, this also decreases, and the negative of E upon RT, this increases, ये बढ़ेगा और ये बढ़ेगा, तो this fraction means e to the power minus e upon RT, this increases, and because this fraction increases, so we can say that the value of K increases. Value of K increases means rate of reaction increases, right? So we see that here with decrease in activation energy, we see that the value of rate constant increases, that the rate of reaction increases. So there is inverse relation between the rate constant and the activation energy, right? So lesser with the activation energy, faster with the reaction, and vice versa, right? So this is the effect of activation energy on the rate of reaction. Okay. Now see the calculation of activation energy. Now there are different methods of calculation of activation energy. See the first one. First one is graphical method. So this is the Arrhenius equation K to the power K is equal to A e to the power minus e upon RT. Take log, इसका हम लोग log लेते हैं. So log K, this is equal to log A, and this becomes log e to the power minus e upon RT, right? Now convert, that is log E to log 10 form. So we know that this is log E. This is equal to 2.303 log 10. तो यहाँ पे हमने 2.303 में मल्टीप्लाई कर दिया, राइट? एंड दिस वैल्यू, इसको आपको पता है कि log a to the power x को हम लोग लिख सकते हैं a x log a. तो इसको हमने इस फॉर्म में कर लिया है. दिस इज minus e upon RT, log e, and the value of log e is 1, so it becomes minus e upon RT. Now divide this equation by 2.303. इसको हम लोगों ने थ्रू आउट हम लोगों ने यहाँ पे 2.303 से डिवाइड कर दिया. सो दिस बिकम्स log k, दिस इज log a, एंड माइनस e अपॉन this is 2.303 RT. So this is also very important relation of Arrhenius equation, right? Now see, from this equation, see the graph between the rate constant and the temperature, sorry, between activation energy. So see, this is the graph between the rate constant and the activation energy. See, if we see the relationship between the rate constant and the activation energy, so we see that there is exponential relation between these two. Here it is becomes e to the power minus a, right? It means that it exponentially decreases. There is negative value. It means that there is exponential decrease with the increase in activation energy, right? So this is the graph between the K and E. So this is important graph. इस पे क्वेश्चन बन चुका है, IIT JEE पे क्वेश्चन आ चुके हैं. प्रॉपर्ली देखिएगा इसको. Next is the graph between the rate constant and the temperature. Again, see here from the Arrhenius equation, rate constant और T के बीच का relation. So we see that here. What is the relation here? Okay, this is here the graph is e to the power 1 upon t. So it is negative value, so 1 upon t की value क्या हो जाएगी? This becomes t. So we see that there is exponential increase with increase in temperature, right? So this is graph is also very, very important. Next is between the log k and 1 upon t. Say from this equation, log k, this is equal to log a minus this is e upon 2.303 r and here 1 upon t, right? So we see that here this is the graph between the log k and 1 upon t. See what is the relation? See, we see here a linear equation. This is y is equal to t minus mx. So in this case we see here a and this is y. This one is the intercept, right? And this is the slope. See here the slope becomes here minus e upon 2.303 r and the intercept here is log a, and it decreases, means there is linear decrease, right? And from here we can calculate the activation energy. So activation energy becomes minus slope into 2.3033 r. So from this equation also we can calculate the activation energy. So in some numericals the value of slope is given and you have to calculate the value of activation energy. Next is between the log k and 1 upon RT. Say here this log k and 1 upon RT, means here it is log k, this is equal to log a minus e upon, this is, we have seen this one, it is actually this is in the exponential form, log a and minus e upon r, and this is 1 upon RT. So put here the 1 upon RT here, right? So इनके बीच में graph plot करना है. See here this is the graph between the log k and 1 upon t. So here this one is in place of m, this is x, this is c, and this one is y. So this one is intercept. So intercept is log a. Slope here is minus m, means minus a. So slope here is minus a. So in this case we can also calculate the activation energy. If the graph is plotted between log k and 1 upon RT and the slope is given, so this becomes equal to negative of activation energy. Next is the graph between the log k and 1 upon t. Again see here from this equation, this is log a, log k, this is equal to log a and minus this e upon r, and this is become 1 upon t. So the graph between the log a and 1 upon t, again see here y, this is equal to c minus m x. So here the slope is minus e upon r. So this is in exponential form. So these are the different graphs on the activation energy. तो इन पे क्वेश्चन बहुत ज़्यादा बनते हैं, इस पे न्यूमेरिकल्स भी बनते हैं, right? Next is experimental method. Now see, let at temperature T1 the value of rate constant is K1, at temperature T2 the value of rate constant is K2. So write the equation of log K1 and log K2 in this form. इस form में हम इस equations को put up करते हैं. So it becomes log K1, this is log A minus E upon 2.33 RT1, and log K2, this is equal to log A minus E upon 2.303 RT2. Now subtract equation 1 from 2, so it becomes log K2 minus log K1, this is E upon 2.33, take common, इसको common ले लिया, so it becomes 1 upon T1 minus 1 upon T2, and from here this one, this log A minus log B form में है, it may be written as log A upon log B, so it becomes log K2 upon K1, and this is E upon 2.303 R, and this is T2 minus T1 upon T2 into T1. So this is another very, very important relation. इस पे भी numerical बहुत ज़्यादा मिलते हैं आपके exams के, right? So this is another method of calculation of activation energy, sure, right? So from here we can calculate the activation energy here, right? Okay, now see the third method. See the third method. At constant T and application of catalyst. That without catalyst, we have taken the reactions without catalyst, without the application of catalyst here, and let EA1 be the activation energy for this reaction, and K1 is the rate constant for this reaction. EA2 is the activation energy when we apply a catalyst, and K2 be the rate constant in this reaction. right? Now we know that with the application of catalyst, the activation energy decreases, because we know that here the catalyst decreases the activation energy by developing an alternate path. तो क्योंकि एक्टिवेशन एनर्जी कम होगी, इसका मतलब क्या है, यहाँ पे EA1 की मैग्नीट्यूड क्या होगी, EA2 से ज़्यादा होगी, राइट? सो EA1 इज ग्रेटर देन EA2 एंड वी हैव सीन दैट relationship between K and EA activation energy is inverse. It means that here K1 is less than K2, right? Now take the ratio of K2 upon K1, so it becomes A e to the power minus EA2 upon RT, and this becomes A E minus EA1 upon RT. Cancel out A and A. Take log K2 upon K1, this becomes log e to the power minus EA2 upon RT, and this becomes e to the power minus EA1 upon RT. और log K2 upon K1, इसको हम लोग क्या करेंगे, log A minus log B फॉर्म में लिख लेंगे, so it becomes log A minus log B. Again log K2 upon K1, log, अब यहाँ पे because the bases are same, इनके bases same है तो इनके powers को हम लोग ऐड कर देंगे, so this becomes this minus this, right? So it becomes log K2 upon log E, and this is EA1 minus EA2 upon RT, or we can say log K2 upon K1, this is EA1 minus EA2 upon RT, this is the delta E. So this is another very very important relation, और कैटलिस्ट पे बेस्ड जो क्वेश्चंस होते हैं वो इस पे बनते हैं, इस इक्वेशंस के ऊपर, राइट? तो इसको आप लोग देखेंगे. Okay, see the next one. See, rate of change of rate constant. See, this is the Arrhenius equation. K, this is equal to A e to the power minus E upon RT. Take log K, this is log A minus E upon RT. And now differentiate this with respect to T. इनको हम लोग T के respect differentiate कर देते हैं. This becomes d upon dt log K, and this is d upon dt log A minus, this is constant value, so put T here, minus E upon R d upon dt, or this is 1 upon T. Now d upon dt log K, this is because A is constant, so this becomes 0, ये पूरा value 0 हो जाएगा, and this is minus E upon RT. और इसका differentiation अगर हम लोग करते हैं, so differentiation of क्या हो जाएगा, this is d upon dx, and x to the power n, it may be written as nx n minus 1, right? So in this way we can write here differentiation of d upon dt, and this is 1 upon t, so this may be written as, it may be written as d upon dt, it is t to the power minus 1, so we put here this is minus 1, and this is t to the power minus 1, right? See, so we get here d upon dt log K, and this is E upon R and into 1 upon T square, right? So when we plot a graph between d upon dt log K, actually this is the rate of change of rate constant, right? So the graph between the rate of change of rate constant and this is 1 upon T square, and see here this is the relation. So we see that in place of M there is E upon R, so slope becomes E upon R. So from this equation also we can calculate the activation energy when the slope is given, and the slope of the graph between the rate of change of rate constant and 1 upon T square is given, so we can easily calculate the value of activation energy. तो यहाँ से भी questions बन सकते हैं आपके, right? So these are the different methods of calculation of activation energy, right? अब आपको इस पे कुछ numericals करनी है. So in the next class we will see some numericals. Thank you very much.